Hi class, today is section 7.3. We are going to prove triangles are similar. The learning target is that you will be able to use angle-angle similarity, side-angle-side similarity, and side-side-side similarity to prove triangles are similar. So this will be very similar to when we prove triangles congruent, except now we're proving them similar. These are going to be the shortcuts you can use. So first, a quick review. What does it mean for two figures to be similar? For two figures to be similar, all corresponding angles must be congruent and all corresponding sides must be proportional. These pentagons are similar. Find the value of x. So you would want to set up your proportion. 15 over 5 is going to be equal to 21 over x. Or you could go the other way and do 5 over 15 is equal to x over 21. Remember, you can flip it. We cross multiply and get 15x is equal to 105. And then divide to get x is equal to 7. Ways to prove triangles are similar. The first way we're going to learn is angle-angle similarity. If two angles of one triangle are congruent to two angles of another triangle, then the triangles are similar. So, are the triangles similar? If so, write a similarity statement. Well, here we can see that these two angles are congruent and these two angles are congruent. So yes, this fits the angle-angle similarity. So now you want to write a similarity statement. We have A, B, C is similar to F, D, E. Make sure you're going in the correct order and matching up your congruent angles. A is congruent to F, so if we start with A here, we have to start with F over here. B is congruent to D, so both of those have to be corresponding. Next one. We know that these two angles are 34, and then we're told that this is a right angle right here. So if this is a right angle, the angle next to it's going to be a right angle. Since this is forming a line, we know it has to equal 180 degrees. If this is 90, then this one has to be 90. Then we also have that 34 and 34 are congruent. So yes, this fits the angle-angle similarity. And we would write that triangle VYZ is congruent to triangle, not congruent, sorry, similar to triangle WYX. Two more similarity theorems. We have side-angle-side similarity. This says if an angle of one triangle is congruent to an angle of the second triangle, and the sides including the two angles are proportional, then they are similar. So what that means is if you have two angles that are congruent, the sides that make that angle have to be proportional. So 6 has to be proportional to 4, and 4.5 has to be proportional to 3. So I should say the corresponding sides that are forming those angles have to be proportional. The side-side-side similarity says if the corresponding sides, all three pairs of two triangles, are proportional, then the triangles are similar. So here we would be looking to see if 10 over 5 is the same ratio as 4 over 2 and 14 over 7. In any case, it's going to be 2 over 1, 2 over 1, 2 over 1. So yes, that would follow the side-side-side similarity. Let's practice. Are the triangles similar? If so, write a similarity statement and explain which postulate or theorem applies. So go ahead and take a look at example 2. Yes, these are similar because even though this angle is 66, we could subtract 66 and 90 from 180 to get that this one's 24. So you can see the 24 and the 24 match up, and the right angle and the right angle match up. So we could use angle-angle similarity to say that triangle GIH is similar to triangle FDE. Sorry, this should be EDF. This one right here should be EDF. It should be EDF. That's written wrong. All right, example 3. I know that these are parallel lines, and that's all I know from this figure. Well, since those are parallel lines, I can say these alternate interior angles are congruent. I could also say these alternate interior angles are congruent. And if I wanted to go a step further, I could say the vertical angles are congruent. But I don't even need to go that far. As soon as you see that two angles are congruent from the triangles, you can use angle-angle similarity. So we're going to say that NJK is similar to triangle LMK by angle-angle similarity. Alright, the last one. All we know on this one is sides. So we would have to see if the sides are proportional. We could do 7.5 over 2.5. And we could do 4.5 over 1.5. So that's only two sides that we would know. We wouldn't know anything about the angles. So there's not a side-side similarity. It has to be side-side-side. And we're missing this last side. So unfortunately, we can't say that these triangles are similar, even though the sides are proportional that we're given. This would have a ratio of 3 to 1, and this one would have a ratio of 3 to 1. Are the triangles similar? If so, write a similarity statement and explain which postulate or theorem applies. So here, we're looking to see if this follows side-angle-side similarity, because that's what we're given in each picture. For that to be true, we would need 4 over 2.5 to be the same thing as 5 over 3. We would need these to be proportional. So if you try that, it's not going to work out. Those ratios are not going to be equal. Alright, on this one, we're looking at the smaller triangle and then the very big triangle. So we're going to be looking for side-angle-side similarity. So side-angle-side and then side-angle-side. So we're looking to see if 10 over 25, that's what the whole thing is the same as 12 over 30. It is. 10 over 25 is going to have the same proportion as 12 over 30, so we can use side-angle-side similarity. What is the scale factor in example 6? So to find this, you would just do two of your proportional sides. We could do 10 over 25, and that's going to give you a scale factor of, or you could do 25 over 10. Either way, you're going to get a scale factor of 5 over 2 or 2 over 5. It just depends which way you wrote it down. So, proving triangles are similar. The 3 ways to do it. Angle-angle similarity, side-side-side similarity, and side-angle-side similarity. If you know that two figures are similar, then you can use proportions to find the missing sides. So in example 1, find the values of the variables that would make the triangle similar. So here, we're given similar triangles. Well, they tell you they're similar. We're trying to find this missing side that would make them similar, I guess. So we know that this is going to be 4 over 9, or it could be 3 over 9. And then we're going to look for x over 4. So we have to try to figure out which way we want to do this. Do we want the 9 to match up with the 3 or the 4? Well, we know this side's going to have to match up with 15. So 15 divided by 3 is 5. So we want to divide 9 by 3, and that's going to give us 3. So we're going to want to match up the 3 and the 9, the 5 and the 15, and the 4 and the x. So we're multiplying by 3 to get to here, multiplying by 3 to get to here. So if we multiply by 3 here, we're going to get 12. Or you can set it up using the proportion. Anyways, it's going to be multiplying by 3. It's going to be 1 to 3, which will give you an answer of 12. So I just talked you through that problem instead of going through and setting up the proportion. Alright, the next one. 4 is going to match up with x, and 5 is going to match up with 8. First, I'm going to find angle y because it's the easiest. We know the angles have to be congruent. It's going to be congruent to this angle right here. The way that you're going to find that is you just do 180 minus 55 minus 90, and it gives you what's left over. So that should be 35 degrees. Then whenever you set up your proportion to solve for x, you're going to get that x is equal to 6.4 and y is equal to 35. The scale factor is 8 to 5. Let's do some application problems. I want you to try these really quick on your own and see if you can figure it out. Alright, the first one, we know this has side angle side similarity because this angle and this angle are going to be corresponding angles because these are your parallel lines. So these are corresponding angles. So we have side angle side, and then we have side angle side. So we're going to do 6 over 8 is equal to 3 over x, or 8 over 6, either way, is equal to x over 3, and you're going to get that x is equal to 4. The second one, you need to draw a picture. We know that she's 5'3", she's casting a 6 feet shadow. We know that the flagpole's casting a 15-foot shadow, so I just added 9. So 9 plus 6 is 15, so that's the whole shadow. And we're trying to find how tall that flagpole is. So before you can do this problem, you're going to want to turn this into a decimal so that it's easier to work with. So that's going to be 5.25 as a decimal. So then you're going to set up your proportion, and you should get that x is equal to 13.125 feet. So that's what we're going to get right here for x. So you do 5.25 over 6 is equal to x over 15. And that's how you get your answer. Alright, I want you to try this one on your own, and I'll see you in class.